Hello. We've been looking at division of double-digit numbers. Today I want to take it one step further and show you an easier way that we can do division of double-digit numbers. Now, as you remember, we've been doing it the Matthew C way. For example, if I had 3 divided by, or 96 divided by 3, or 3 into 96, we were looking at 96 as 90 plus 6. And we were asking ourselves, how many times does 3 go into 90? Well, 3 goes into 90 30 times. 30 times 3 is 90. 6 minus 6 is, or 6 minus 0 is 6. 9 minus 9 is 0. Then we asked, how many times does 3 go into 6? 3 times 2 is 6. 6 minus 6 is 0. Okay? So that's how we've been doing it. However, that's a really strange way of looking at Matthew C, particularly for those of us who have grown up doing it the easier way. And yes, there is an easier way of doing this. Let's have a look at the same question. 3 goes into 96. Well, let's pretend that that 6 is not there. Now we can ask ourselves, how many times does 3 go into 9? A little bit easier to handle. 3 times 3 is 9. 9 minus 9 is 0. Now don't forget though, we still had this 6 here. So what do I do with that? Well, I can't go 3 into 0 because the 0 is smaller than the 3. So I need to bring the 6 down. Okay. 3 times what is 6? Well, that's easy. 3 times 2 is 6. 6 minus 6 is 0. So you can see this is a far easier way of doing this. I don't have stacking numbers. I don't have to, multiply in tens and anything like that. Much easier. Let's do another example. Let's take a number like 93 divided by 6. Okay? So again, I'm going to pretend that that 3 is not there. So I can ask myself, how many times does 6 go into 9? Much easier. Before I would have had to ask, how many times does 6 go into 90? But I don't have to do that with this way. Much easier. Smaller numbers. I like smaller numbers. Doesn't make my brain hurt as much. So, 6 goes into 9 one time. 6 times 1 is 6. 9 minus 6 is 3. But wait, you say, Mr. Hancock. Wait, Mr. Hancock. What about that 3 that was there? Oh, well, I can't go 6 into 3 because that's too small. So I'm going to bring this guy down and make it 33. Ah, now I can go 6 into 33. Much nicer. Alright, so 6 times what equals something close to 33? Aha! Well, what if I go 6 times 5? 6 times 5 is 30. Three minus 0 is 3. 3 minus 3 is 0. So now I'm left with a 3, which is smaller than my 6. And since I don't have any other numbers to bring down, I'm stuck with the 3 as my remainder. Can you see how easy this is compared to the other way? Let's try another one. Let's go with, let's pick 4 into 83. Okay. I'm going to just get rid of that 3 for a minute. And that leaves me with 8. Okay. So how many times does 4 go into 8? Aha! Again, smaller numbers. Nice. I like it. So 4 times 2 is 8. 8 minus 8 is 0. But wait, Mr. Hancock, what about that 3? Ah, yes. Let's not forget about that 3. So since I can't go 4 into 0, because the 0 is too small, I'm going to bring down his little buddy, this 3. And that makes it a 3. Now again, the 3 is smaller than the 4, so I have to go 4 times 0 is 0. I'm going to subtract 3 minus 0 is 3, and since the 3 is still smaller than the 4, I got a remainder of 3. Okay, let's do another one. Let's go with 7 divided by 87. Okay, so I'm going to leave the 7 there this time. And so I'm going to look at 7 going into 8. How many times does 7 go into the 8 there? Well, 7 times 1 is 7. 8 minus 7 is 1. Now the 1 is smaller than the 7. So I can't go 7 into 1. So I'm going to bring down his little friend, which makes that 17. Now I can ask, how many times does 7 go into 17? Well, 7 goes into 17 2 times. 7 times 2 is 14. 7 minus 4 is, everybody? Good. 3. 1 minus 1 is 0. Now, my 3 is smaller than my 7, and I don't have anybody else to bring down, so my remainder is 3. And that is the faster way and the easier way of doing 2-digit division. But what's made it easier is that we have a better understanding of why the numbers go where they go and where we are getting them from. So we're going to be doing that for a little bit, and then we're going to move on into 3-digit divided by 1-digit.